Complex zeros are next in 2.5 day 1. We just talked about the theorems, the linear factorization theorem as well as the fundamental theorem of algebra. Talked about the possibility of there being complex zeros or complex numbers there. One thing to remember is that complex numbers are any numbers written in the form a plus bi. So that oftentimes can just mean anything. But a lot of times when they refer to complex zeros, they're going to just be mainly talking about imaginaries. Here, however, we're just going with the all-inclusive definition, complex ones, including real zeros, including real numbers. So, for instance, 5 is the same thing as 5 plus 0i. That's why it can be a complex number. If we wanted to if we just had, like, let's say 4i, that would be considered complex because you could write it as 0 plus 4i. So pretty much any number that you write can be in that form. Now, remember some of the imaginary basics. I is the same as the square root of negative 1. I squared is equal to negative 1. Those are going to come in handy as we're simplifying things, combining things together, so keep those in mind. But here's a really important rule. This is the main thing I want you to get from this slide, is that complex zeros, and in this case we're talking imaginary specifically, they always come in pairs. That is super important. For instance, down here, here's a pair. They come in a conjugate pair. Negative 4 plus 2i, negative 4 minus 2i go together. If I were to have something like 3i, then it would have the partner of negative 3i. They're always going to come in pairs. That's something that you can know for sure. That will come in handy very soon as we start looking at examples.